Good afternoon. It's me, Mr. Werger. The math department has a meeting this afternoon. We had a guest speaker come in to talk to us. So unfortunately, I'm not able to be at class today. But the show goes on. Hopefully the substitute handed out the note sheet for today. So this is the start of our last unit. This unit will go right up until winter break. And then after winter break, we'll have a week to review, and that's about it for the semester. So things are going to be winding down pretty soon. Why don't we make it a goal to try to keep up with all the homework this unit? So when you have work time, get this assignment done. Turn it in at the end of class. Don't let yourself fall 2, 3, 4 assignments behind like some of you have done throughout the semester. Makes it much more difficult that way. Okay? Okay, so today's lesson is probably the most difficult lesson we have left this year. After this, it's much easier. But let's all pay real good attention to today's lesson because part of it's not too hard, but part of it is going to be more challenging. Okay? We need to be prepared to use the Pythagorean theorem, which we learned earlier. A squared plus b squared equals c squared. So that will come up on not every problem, but it'll come up on a few problems. And SOHCAHTOA is going to come up again on a few problems. S was sine, so the sine of an angle is opposite over hypotenuse. C was cosine, cosine is adjacent over hypotenuse. T was tangent, tangent is opposite over adjacent. If I went too fast there, substitute, feel free to pause the video at any time to let people get caught up. We haven't done sine, cosine, tangents for a while, but that will come up. Okay? So back in our first unit on quadrilaterals, we learned about kites and rhombuses. I guess I should say this entire unit is about finding the area and finding the volume of objects. Okay, so today is the area of a kite, area of a rhombus, and then we're going to get to the area of regular polygons. Okay, so the kite and the rhombus part is not too difficult. Remember what a kite looks like? Like a kite, right? Has two pairs of congruent sides, but they're not across from each other, they're next to each other. And diagonals go across the kite. So those dashed lines I just drew, those are diagonals. Okay, so to find the area of a kite, you need to know the diagonals. And if you know the diagonals, it's pretty easy. So formula for area of a kite, 1/2 d1 times d2. And d1 and d2 are the diagonals. So the diagonals. 1/2 d1 times d2. Okay? Should we skip down to an example here? Let's skip down to example 2. That's kite, right? So from the bottom to the top, that's one of the diagonals. That's 11. Going from the left side to the right side here, that's another diagonal. Says that's 5. So 1/2 times 5 times 11. That will give you the area of the kite. So if you got a calculator, type that into your calculator. We should get what? 27 1/2, 27.5. And then we should add units in our answer. So this was in feet. So remember we talked about area, we're finding space. So this would be in square feet. So we abbreviate that feet to the second power, square feet. Pretty straightforward, right? 1/2 diagonal 1 times diagonal 2. Okay, rhombus. So rhombus, all 4 sides are congruent. A rhombus may or may not have right angles, but the 4 sides are still congruent. That's a rhombus. So the diagonals of the rhombus would again go across from one corner across to the other. Okay, so the nice thing is that the rhombus has the exact same formula for the area as the kite. So remember one formula for both rhombus and kite. 1/2 diagonal 1 times diagonal 2. Same formula as kites. One half diagonal 1 times diagonal 2. So example 1 there, that's a rhombus. All 4 sides are congruent. And you're given the diagonals here, that's 24, that's 10. So do 1/2 times 24 times 10. So 1/2 of 24 is 12. 12 times 10, multiply by 10, you just throw a 0 on the end of it, right? 12, throw a 0 on the end of it. So, or you could do 240, take 1/2 of 240, you get 120. Units here were in millimeters, so area will be in square millimeters. Square millimeters. If you have any questions on that, hit pause, discuss. Otherwise, hopefully that's pretty straightforward, right? 1/2 times diagonal 1 times diagonal 2. Okay, the more challenging part of today's lesson is finding the area of a regular polygon. So a regular polygon, if you remember, all the sides are congruent. And all the angles are congruent. All the sides are congruent, all the angles are congruent. And that's called a regular polygon. Okay? Let's see here. A regular polygon has a radius. So the radius is going to go from the center. So there's going to be a point that's right in the middle of the polygon. So going from the center out to one of the corners of the polygon, that's called the radius. Kind of like the circle, the radius went from the center out to one edge of the circle. Okay, so it's a little different with polygons, so it has to go to a corner. Okay. There's another line that goes from the center to the midpoint of one of the sides. That right there. From the center to the midpoint of one of the sides. And that's called an apothegm. New term. Essential for finding the area of a regular polygon, the apothegm. Did I mention that was super important? So the apothegm is the distance from the center of the polygon to the middle of any side of the polygon. The distance from the center to the middle of one of the sides. That is called the apothegm. So that line right there is the apothegm. Okay? And the apothegm is going to make a right angle with this side. So we have a right triangle here. Okay, so that's where the Pythagorean theorem and SOHCAHTOA are going to come in. So if we don't know what the apothegm is, we might be able to use either SOHCAHTOA or the Pythagorean theorem to find the length of the apothegm. Okay? Then one other important part here, something called a central angle. So if I draw another radius here, so I've got this triangle right here. Okay, so we've kind of talked about central angles previously when we were doing circles. Okay, so that angle right there, that's called a central angle. So how many central angles are there for this regular, remember what we call this shape? 5 sides? 5 sides was a pentagon, right? Pentagon. So how many central angles are there in a regular pentagon? So if I do a radius out to each corner, how many central angles are there? Let's count them up. 1, 2, 3, 4, 5. There's 5 central angles, right? And because this is a regular polygon, all the sides are the same. That means all the central angles are going to be the same. So how could we figure out what one of those central angles is? All 5 of these angles have to add up to what? It's like going around a circle. All 5 of them need to add up to 360. then we would divide by, we said there are 5. So however many sides there are, that's going to be the number of central angles. So we're going to do 360 divided by n. N is the number of sides. Any questions on that? Okay, so on the top and back side there is some practice finding central angles. Okay, so M stands for measure. So angle KPJ. So the angle formed going from K to P and P to J. Okay, so that's a central angle, right? So I would do 360 divided by, now we want to count up how many sides there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a decagon, right? Getting in some early review for the semester exam. Polygon with 10 sides is a decagon. Okay, so if we do 360 divided by 10, that's going to be 36 degrees. Not too bad, right? Okay. Angle LPK. LPK. Does that look like it's half of the central angle? I mean, our apothem goes to the midpoint here. So it makes sense that the apothem would cut our central angle in half. And it does. Okay, so take half of 36. 36 divided by 2, that would be 18. Half of central angle. Okay, and the last one on there is the measure of angle LJP. LJP. So that's that angle right there. Remember, the middle letter is going to be the vertex. LJ and JP, where those two sides meet and form that angle, that's the angle. Okay, so how can we figure that out? Now remember triangles, the angles add up to 180, right? So we've got a 90-degree angle up here. This angle is also going to be 18. So if we do 180 minus 90 minus 18, what's left is going to be that angle right there. Looks like 72. Okay, now we get to the more challenging part. Area of a regular polygon. So now we're finding the space inside this regular polygon. So I guess the nice thing is that it's the same formula regardless of the shape. So it can be a regular pentagon, it can be a regular hexagon, it can be a regular octagon, it can be a regular 25-gon. The formula is the same. So it's not like we have one formula for circles and one formula for triangles and one formula for trapezoid, whatever. It's the same formula for all regular polygons. Okay, so super important formula, 1/2 times A. A stands for the apothem. So that's why apothem is super important, because it's right here in the formula. 1/2 apothem times P, which is the perimeter. 1/2 apothem times perimeter. Okay, so not a super complicated formula. And depending on the problem, so some of them aren't that hard, like this one. We're going to do 1/2 apothem times perimeter, so 1/2. Do we know the apothem? The apothem is from the center down to the middle of one of the sides, so there's the apothem right there. It's 9. Do we know the perimeter? No, but we could figure it out, right? The perimeter, we're adding up all of the sides, going around the outside of the, what shape do we have here? 1, 2, 3, 4, 5, 6, 7, 8. We have an octagon. So can we figure out the perimeter of that octagon? It tells us that this side is 7, and then it also tells us that every side is the same length. That's what the little tick marks are. So this is a regular octagon. So the perimeter would be 8 times 7, right? Each side is 7. There's 8 sides. So 8 times 7 is going to give you the perimeter. So that's 56. So 1/2 times 9 times 56. And that's going to be our answer. 252. And there were no units given in this problem. It doesn't say inches or centimeters or anything. So we can just call them generic. This is 9 units. This is 7 units. So then our area, we'll just say 252 square units. Okay? Just checking to make sure the video is still going there. Last time it stopped on me. Okay, now it'll get a little more difficult. Here we have a regular pentagon, right? So again, it's going to be the same formula, 1/2 apothem times perimeter. And we do know the apothem, 6.5. Okay, but we do not know the length of one of the sides. So we're going to have to do a little more work to figure that out. Okay? So we do know the apothem and the radius. And we know this is a right triangle. So what could we use to find this side of the right triangle? know two sides, we can use the Pythagorean theorem, right? To find this. Okay, and then that is half of the side of the pentagon. So if I find this, and then multiply by 2, that gives me that whole side. And then I can multiply by 5 to get the perimeter. Okay, so perimeter is a little more work. So let's do the Pythagorean theorem. Remember, c squared is the hypotenuse. I'm going to call that x. So we got 6.5 squared plus x squared equals 8 squared. A squared plus b squared equals c squared. Okay, so 6.5 squared is 42.25 plus x squared. 8 times 8 is 64. Okay, so then we will subtract 42.25. Squared equals 21.75. Then take the square root. And we should get about 4.66. Don't go away. I'm not going away, I'm just opening my calculator here. Okay, so let's try not to round in the middle of a problem, because then your final answer is going to be off if you do round in the middle of the problem. So I'll show you on the calculator like how we can avoid rounding. Okay, so we did 64 minus 42.25. Oops. 42.25. Okay, now we're taking the square root. So if you've got like an answer button, use that. Some of you have calculators with an answer button. Otherwise, if 21.75 shows up, and then you just hit shift and then the square root button. Okay, so we've got 4.663689.527. Okay, so we want to use that whole thing. We don't want to round it. Okay, so remember that's half. That's half of one of the sides of the pentagon. Okay, so now we're going to multiply that by 2. Okay, so like leave that number in your calculator. Don't like clear and then just type in 4.66. Use the whole thing. So times 2. Okay, so now I have a non-rounded answer there. So that's the length of one of the sides of the pentagon. And now what am I going to do with that number to find the perimeter? I'm going to multiply by 5, right? Because there's 5 sides. So not rounding, using the whole thing, times 5. Okay, so there's our perimeter, 46.6. So here I want to do times 46.6. Okay, but again, I'm not gonna round it, I wanna use that whole number that's in the calculator. So then I need to do times the apothem, 6.5, and then times 1/2. Okay? So perimeter times 6.5 times 0.5. Okay, now we've got a very precise answer for the area of that pentagon. We didn't do any rounding, but hopefully you can see that if you round like at each step, like if you make this 4.66 and you make that 9.33, so you're off there, and then you round again. Like if you round 3 different times, that's your answer is going to be off. Okay, so let the calculator just remember the whole thing. Like if you want to write down like part of it, you know, just as you're doing your steps, but don't hit the clear button on that calculator until you're completely done. 151.57 will be our final answer. Okay? Square units on that. Okay, I hope that made sense. Two more examples. Okay, here we have a mirror shaped as a nonagon with 6-inch sides. What is the area of the mirror? Okay. So easier to find the perimeter, right? Perimeter, each side is 6. Says it's regular, that means all the sides are the same length. Says it's a nonagon. We don't remember what that is, we could count up the sides. There's 9 sides. So our perimeter is 50. Okay, the difficult part of this one is finding the apothem. We don't know the apothem. So here's where the central angle is going to help us. So I can find the central angle. Age just disappeared. There it is. Whew. I was working there. Okay, so I can find the central angle, right? Remember 360 divided by the number of sides. So 360 divided by 9. Nonagon, that's going to be 40. Okay, so the whole central angle is 40. Okay, but we're going to focus on just half of that triangle. Half of that triangle is a right triangle. Got a right triangle right there. Okay, so this angle would be half of 40. So maybe we should draw this triangle a little bigger here. So this angle is 20. And then this bottom side here is gonna be half of 6, right? 6 is the whole side of the mirror. So this triangle is half of that. So that's 3. Oh, the smartboard is not cooperating. What happened to my smartboard? Let me try this. Sorry if you want to fast forward through our technical difficulties here, go ahead. Oh man. Smartboard has stopped. What to do now? Oh, it's back. Oh, smartboard. Just slowly down. Why don't you fast forward through this part, so I'll give you a thumbs up when it's working again.